A mysterious messenger from outside our solar system appeared to behave in ways that suggested it might have a mission. Its behavior was puzzling, leaving astronomers and planetary scientists alike questioning its nature. The truth of the matter began to unravel on the night of July 1, 2025. The Atlas telescope array in Chile flagged an object moving against the backdrop of the stars. It was a faint, fast blip, catalogued at magnitude 14. At first glance, software tagged it as another long-period comet inbound from deep space. But this object, which would soon be given the provisional label 32 Atlas, was anything but ordinary. Gemini South and Hubble telescopes joined in to confirm the find, each logging the same coordinates and revealing a dust halo just barely visible in the stacked exposures. As astronomers began computing the object's orbit, they discovered that it was following a hyperbolic track retrograde, with a high inclination and unmistakably interstellar. This was only the third known interstellar object, following Oumuamua and Borisov. Initially, calculations showed that the object would pass safely by Mars, with no immediate threat to any spacecraft or surface mission. Its speed, nearly 87 km per second relative to the Sun, was remarkable, but not uncommon for a comet. Spectra taken at this point, albeit limited by the object's faintness, showed a coma dominated by carbon dioxide, with hints of water vapor, essentially a typical comet. For the survey teams, 32 Atlas was a rare curiosity, but it still fit the expected mold of a comet. The discovery log closed with routine remarks, and no one suspected what would unfold in the weeks to come. Fast forward to August 7, 2025. The JPL Orbital Dynamics team, now joined by Harvard's astrometry group, began recalculating the trajectory of 32 Atlas after receiving a week's worth of new positional data. The object's speed, locked at nearly 87 km per second, placed it among the fastest bodies ever tracked, fast enough to cross the Earth-Moon gap in under 80 minutes. At this velocity, even the slightest change in course could mean the difference between a harmless flyby and a direct collision. Over the following days, covariance plots became more refined. The predicted miss distance to Mars began to shrink not by millions of kilometers, but by hundreds of thousands with each new set of data. The analysts flagged non-gravitational residuals in the trajectory, tiny deviations that couldn't be explained by solar heating or the typical behavior of a comet. With each update, the trajectory bent closer to Mars's orbital plane, and an unsettling sense of unease began to grow. The object seemed to be on an increasingly unlikely course, and dynamicists ran delta-v simulations to account for potential course changes. They found that even a small change in velocity, say 10 km per second, applied over weeks through outgassing or some unknown means, could bring the object dangerously close to Mars. The numbers were concerning. The precision of the flyby was beginning to feel like a high-stakes game of cosmic roulette. Each new trajectory update amplified the stakes, and a question loomed larger with every passing day. Was this just cosmic chance, or did the object's movements suggest intent? On August 14, 2025, the Mars Reconnaissance Orbiter Science Unit logged a sudden and inexplicable doubling of 32 Atlas's apparent brightness. The spike came with a surge in ultraviolet output, something never before observed in a comet. The event, captured in back-to-back photometric sweeps, was neither gradual nor chaotic but appeared to be a precise, twofold jump in intensity, as if the object had somehow flipped a switch. This wasn't a random outburst. It was something calculated. Spectroscopy teams on Earth and at Mars began to sift through the data, uncovering a disturbing pattern. Every 17 minutes, a fresh burst of carbon dioxide erupted from the nucleus of the object, each one timed with almost mechanical precision. The jets were not scattered at random angles, as one might expect from a comet, nor did they drift with the rotation of the object. Instead, each pulse seemed to align perfectly with Mars's orbital plane, as though following a carefully preset schedule. This pattern held for days, with the MRO's ultraviolet sensors capturing the same rhythmic bursts. Amateur astronomers observing the object in green wavelengths reported seeing 3 needle-thin tail filaments pulsing in unison, always pointing toward Mars. This triple stream, faint but persistent, seemed to match the 17-minute cycle logged by professional observatories. No known comet in the solar system had exhibited such disciplined clockwork venting, especially one traveling at nearly 90 kilometers per second. For planetary science teams, the anomaly wasn't just in the numbers, but in the choreography of the outgassing. The jets were so regular, so directional, that it hinted at something far beyond the scope of solar heating or the behavior of ordinary comets. The question, once again, was sharp and pressing. Was 32 Atlas simply the most extreme comet ever tracked, or was it operating with intent? By September 15, 2025, the mystery deepened. An anonymous technician from the Goldstone Deep Space Network relayed a single, chilling sentence to a colleague: "No iceball bounces radar like that." The first deep space radar pings aimed at 32 Atlas as it neared Mars returned sharp, hard signals that had only ever come back from metal objects, not from icy comets. The raw data suggested that 32 Atlas was not just any comet, but a dense, compact body with a mass estimated to be near 10 billion tons. The object, if solid at its core as the radar data suggested, could span nearly 400 meters across, comparable to the largest metallic asteroids, but it was traveling at a velocity that no asteroid in the inner solar system had ever matched. Impact simulations followed. At 57 kilometers per second, a direct strike from 32 Atlas would release energy equivalent to 2 million megatons of TNT. This would be enough to excavate a crater 60 kilometers wide and 5 kilometers deep, reshaping a region of Mars in mere seconds. The debris models were even more unsettling, predicting that the resulting ejecta could threaten orbiters, relay satellites, and even interplanetary space. The numbers left little room for doubt. This was no regional hazard, but a planetary-scale risk. As the radar data circulated, a second leak surfaced. The European Space Agency's Mars Express, in reviewing its image archive, flagged 3 glinting points near 32 Atlas. These points formed a perfect triangle, frame after frame, as though they were stationary and accompanying the object. The geometry was far too precise to be random debris. Analysts debated whether this could be fragments, escorts, or even reflections from nearby surfaces, but the pattern persisted across multiple exposures. For the planetary defense teams, this new evidence, the mass, energy, and now the geometry, was impossible to reconcile with the behavior of a natural comet. The threat was no longer theoretical. The object's true nature, and its possible origins, were becoming clearer by the day. The question now was not if 32 Atlas was a danger, but who or what was steering this interstellar visitor toward Mars. By September 19, 2025, the world's top